All right, like I said, on Chem 110 exams, the two big things that students struggle with are unit conversions and naming. So make sure you know how to name things going backwards and forwards, and practice it until you get sick and tired of it. I know it takes a lot of work and can be tedious, but the more you practice it, the easier it is. First thing you always want to do is identify whether or not your compound is ionic or covalent. We said covalent compounds are between two nonmetals, and ionic compounds fall into three categories. It's either something that contains a metal, a transition metal, or one of the polyatomic ions. And like I said, one of the easy ways to spot a polyatomic ion is you've got a compound with more than two atoms, right? If you're naming covalent compounds, that's when you need the prefixes. Ionic compounds don't. However, if you've got a transition metal, that's when you need that Roman numeral. So let's do a few practice ones. Oops. And what I want to do is go from a molecular formula to a name. We'll do MgCl2 for our first one. And then for the second one, we'll go KCN. And then for our third one, we'll actually do a name to a molecular formula. Do potassium phosphate. So I'll give you a minute to look these over. You may want to check with the neighbor and confirm that you're structuring your name or molecular formula the same way. All right, let's try to do this as a class, and I'll kind of show you my thought process that I like to do when I'm naming these. So we'll start with MgCl2. First thing I want to do is identify whether or not it's ionic or covalent. So what would this one be? Ionic. It would be ionic. So I'll just label that. I'll say ionic. Then I'll say no transition metal. So it's in that naming category. Okay, now what we need to do is figure out our naming system. Do we need prefixes? Nope, we don't need any prefixes. So this one's pretty easy. It's just magnesium chloride.
Will we have like a sheet like this of common ions, or we just remember them?
So I wanted you guys to use that Quizlet game as a way of remembering polyatomic ions. I know it takes a fair amount of work, but I tried to trim them down to just the bare essentials that you need to know in biology and other science classes.
So there's a Quizlet on this?
Yeah, on the website I have the Quizlet link, and you can play that matching game, or even just make flashcards and put them next to your bed. Okay, so the next one, KCN. Let's first determine whether or not it's ionic or covalent. What do you guys think? It's got to be ionic. There's a metal in there. So we'll say ionic. It has no transition metal, which is good. We don't need to deal with that Roman numeral. However, we do have a polyatomic ion. Specifically, the anion is polyatomic. Like I said, the easiest way of telling is right now we've got three different element types. That means it's got to be polyatomic, right? It's a simple way of telling. Okay, so let's try to break it down. We know the first part has to be potassium. Does anybody remember what CN is for the polyatomic? Cyanide. It's the common poison. Another weird trivia thing is apple seeds actually contain cyanide. So if you have, let's say, a horse and you've got a bunch of apple trees, you actually have to watch out that your horses don't eat too many apples, or else they can get sick from cyanide poisoning. All right. Potassium phosphate is arguably the hardest one here. Is this ionic or covalent? It's got to be ionic. It's got a metal. It has no transition metal. And again, this one has a polyatomic anion. Okay, so let's try this. We know potassium The elemental symbol is K. And what charge does potassium always have? +1. So I'll just write 1 plus here. And then phosphate is a polyatomic anion. Does anybody remember the formula for it? It's PO4. And what charge does it have? Yeah, -3. And if you remember, one simple trick is you can take this, swap it out over here, and flip it around. So for example, the potassium, if we pull that 3 over, should have a subscript 3 next to it, indicating you need 3 potassium cations to cancel out the phosphate. And then we have PO4. It's important to note too, if you have more than one polyatomic ion, put parentheses around them.
Could you explain that transfer to 3 and 1, why that isn't like 2? Or
So you can quickly take the charge and swap it over and use that to figure out how many of each you would need to make a neutral molecule, right? So another way of writing this, sorry, I'll go back and finish that note, is we could say, all right, let's say we've got 3 potassium cations. That would cancel out my phosphate, which has a 3 negative. So really quickly you can do that flip and switch in order to figure out your molecular formula. Yeah. So if you have more than one polyatomic ion, use parentheses. I'm not sure if I spelled that right. I'm hoping I did. This is why I don't teach English. So we'll do an example of that one that we saw previously, where we had calcium hydroxide, where we did CaOH2, and we put parentheses around the OH to indicate that we have 2 of those. You do want to use those parentheses to indicate the number of polyatomic ions you have if it's more than 1. Does that make sense? All right, I've got a few more warm-up problems. First one is the correct formula for the ionic compound formed from the elements potassium and oxygen would be what? So this would be an example of an exam problem. So potassium always has what charge again? 1 plus. Oxygen has what charge? 2 minus. We can go ahead and we can say, all right, we're going to do the flip trick. That means that it must be K2O, right? So for this one, the correct answer would be B. So learning those simple tricks can sometimes make your life a lot easier. If you prefer actually drawing out the atoms and visualizing it that way, you're more than welcome to. Does that make sense? All right. What is the correct name for this compound? Give me a thumbs up if you feel confident. All right, first thing I would do is identify it as ionic or covalent. It's got to be ionic, it's got a metal in there, which means we can cross out some of these with process of elimination. For example, that one doesn't make sense because it has a prefix in there. All right, second thing I would say is, all right, is it a transition metal or a non-transition metal? Transition metal, copper's in that middle section. So it does need a Roman numeral, which means I can cross out these two. Now the question is, will the copper have a +1 or a +2 charge? Let's think about it this way. What's the charge on the chlorine? Be 1 negative, right? That means the copper, in order to balance it out, must be 1 plus, which means B would be the correct answer there. Does that make sense? Because we know chlorine's always going to be -1 when it's ionic. All right, I think I just have a few more. There we go. Which of the following would be the correct electron dot or Lewis structure for nitrogen gas N2? So you may want to practice this on your scratch paper. I'm going to get us started down here. We've got 2 nitrogens. How many valence electrons do we have on nitrogen? 5. So I'll just go ahead. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We want to pair up electrons and try to get octets if possible. So I'll pair that one, pair that one, pair that one. Looks good to me. That means we have a nitrogen-nitrogen triple bond with lone pairs on the outside. So the best one for this one has got to be E. That's the only one with the triple bond in between with lone pairs outside. So make sure you can practice with Lewis structures, especially with double or triple bonds. Yeah, in some Gen Chem textbooks, they don't show the dash line. Because I'm an organic chemist, I really like just showing single lines to indicate that's a bonding pair, not a lone pair. It, in my opinion, makes it a lot more clear. All right, let's go to the next one. Carbon monoxide, CO, is a colorless, odorless, toxic gas. Which of the following best describes this molecule? First of all, do you think it's ionic? Can't be ionic. It doesn't have any metals or polyatomic ion, so I'll cross that one out. Next one's looking at polar versus nonpolar. So what I would like to do is try to draw the Lewis structure for this one. So carbon monoxide, we know we have 1 carbon, 1 oxygen. The carbon has 4 valence electrons. Oxygen has 6. This is a tough one for the Lewis structure. And I'm going to pair this one up. And I'm going to pair this one up. However, if you look at the carbon, it still has 2 unpaired electrons. So what I'm going to do is pair this one up. However, we're still not in a very good position right now. Let's just draw our product from pairing these. We've got a triple bond. We can't go to a quadruple bond. That doesn't exist. And then we've got a lone pair here and a leftover electron here, right? So this is our incomplete Lewis structure. All right, we said that electrons really want to be paired and atoms really, really want to have octets, right? So if we look at this oxygen over here, right now I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons around it, and one of those electrons isn't paired. What would be a simple solution? Just kick one out, right? Say, all right, you go away. We don't want you there. All right, if we kick off that electron from the oxygen, now that oxygen's got an octet of electrons and full lone pairs, or full paired electrons. All right, the carbon over here, if we look at that, it's got 2, 4, 6, 7 electrons around it and an unpaired electron. So what we might want to do is say, hey, let's just take an electron and shove it in that missing spot right there. That way we've got an octet and we've got paired electrons. Okay, what I'm going to do is I'm going to redraw this now. We still have that triple bond in between. The oxygen now just has a lone pair. It doesn't have that unpaired electron. And that oxygen, what charge should it have if we yanked away an electron? Positive. Okay? So the oxygen side's got to have a positive charge because we yanked out an electron. The carbon over here, we added an electron to. Now it's got an octet, full paired electrons. What charge should the carbon have? Negative. We gave it an electron. All right, now the weird question. What's the charge for carbon monoxide? Neutral, right? You have a positive and a negative, they cancel out. So the overall molecule is neutral, even though carbon is formally negative and oxygen is formally positive. All right, now the tricky question. Which side is electron rich? Oxygen. Yeah, you don't want to overthink that one. It's got the negative charge. So it'd be negative, positive. Does that mean that this is a polar compound or a nonpolar compound? It's got to be polar, right? Because there's unequal distribution of electron density. So now we can say, all right, it's got to be polar covalent bonding with the carbon end being more negative than the oxygen end. So this was pretty challenging. I think Mohammed sent me an email over the weekend asking about CO, and I wanted to show you guys some of the weird examples with Lewis structures where you have to add or remove electrons to get pairing in an octet.
What's making that happen besides just needing that to
Really, Lewis structures are a theory. It's just used to explain physical phenomena. And so in this case, the theory of wanting complete octets and paired electrons makes sense. And we know that the bond in between the carbon and oxygen is more triple bond-like than double bond-like.
So if it's in theory on the test, we can explain what we're doing.
Yeah, I want you guys to put your best foot forward. So if you are ever stuck, you can try to write me a little note explaining your thought process. Yeah. Yep. So the carbon in this case, because it has a negative charge, is the more electron-rich side. It's weird because normally we think of oxygen as being more electronegative, but in this case, the formal charge actually has the negative charge on carbon. Yep.
So the electron on the oxygen isn't just going to the carbon, right? It's like going away and then a different electron is going to the carbon?
Yeah, this is just a visual representation I do. So I show it like, hey, we're yanking this electron out. That way we have complete octets. That means that oxygen has a positive charge. It doesn't matter where it goes, if that makes sense. And then for the carbon, we're just stealing an electron from somewhere else to get a complete octet. Yeah.
Could you explain the electron-rich?
Yeah, so if you're electron rich, that means you've got an abundance of electron density, right? And if we look at the carbon and carbon monoxide, the carbon has a full negative charge. That means it's very rich in electrons. So that would be the electronegative side of the atom, or electron rich side, if that makes sense. It is weird. I'll be honest with you, this is more advanced than what I would throw on a normal exam, but I did want to explain your question that you emailed me.
How do we know that it wouldn't be a double bond with oxygen? Just keep two pairs.
That's a good question. So you're asking, why don't we draw it like this? And that would mean that the carbon would have one lone pair. You can draw it like that, but it looks really weird because carbon doesn't have an octet. It only has 6 electrons around it. That carbon is very unhappy. Ideally, if you can, you want to have a complete octet of atoms around there. That's a good question, though. All right, let's do, I think I've got a couple more just practice ones. According to valence shell electron pair repulsion theory, a molecule with 3 bonding pairs and 1 lone pair of electrons will have what structural shape? So I'll show you what they mean. It says 3 bonding pairs and 1 lone pair. So let's say I've got a central atom X. I've got 3 bonding pairs, and I'll call this to atom A. And then 1 lone pair that looks like that. What would the overall shape be? Let's try to rule some out. We know it's not linear. That doesn't make any sense. Square planar, we didn't even cover that one, so it's a big clue it's not going to be that one. Tetrahedral means you've got 4 things on there. So tetrahedron, 4 things. It's not that. We only have 3 bonded atoms. So now we're stuck between triangular planar or trigonal pyramidal. What do you think? Will this be planar? No, it'll form a pyramid in 3-dimensional shape. So this would be the appropriate answer for that one. All right, last but not least. Which of the following best describes the bonding and polarity of dichloromethane? I'll give you a hint. Chlorine is more electronegative than carbon. So if chlorine's more electronegative, we're going to pull electron density towards each of the chlorines. The average pull is going to be in between, right? So that would be a net dipole going that way. So in this case, it looks like we've got polar bonds and a polar molecule. So I would say D would be the correct answer for this one. We've got individual polar bonds and a net imbalance of electron density. Does that make sense? All right, so the rest of the period, we've got 20 minutes. We're just going to do all nomenclature practice. I really recommend pairing up or even forming a bigger group than a pair and see if you can work through it together and check each other's mistakes. Finding somebody's mistakes not only helps them, but it helps you remember it too. At least for me, I always like spotting mistakes. All right, I'll give you the rest of the period to work on that.